In many applications in statistics, we are interested in constructing intervals around the center of our observations that contain certain percentages of our observations. This is being made possible by a theorem called Chebyshev's theorem. And for any population with mean m and standard deviation is d, the percentage of observations that lie within k standard deviations from the mean must be at least 100 times 1 minus 1 over k squared. Let's see what it means. For k equal to 2 standard deviations, 100 times 1 minus 1 over 2 squared is 75%. That means at least 75% of our observation lie within the interval which starts from mean minus 2 standard deviation until mean plus 2 standard deviations. For 3 standard deviations, this formula 100 times 1 minus 1 over 3 squared is almost 90%. That means at least 90% of our observation lie in interval which starts from m minus 3 SD and ends in m plus 3 times standard deviation. Now, let's see this Chebyshev's theorem in a normally distributed statistical variable. This is the graph of a normally distributed statistical variable whose mean is here at the center. Now you know when we have a normal distribution, this is the center, this is mean, which is also equal to median. Now the interval which starts from the mean minus 1 standard deviation and ends at mean plus 1 standard deviation is this interval here. This interval contains 68.26% of our observations. The interval which is a little bit wider, starting from mean minus 2 times standard deviation and ends at mean plus 2 times standard deviation, contains 95% of our observation. Likewise, a wider interval which starts from mean minus 3 times standard deviation and ends at mean plus 3 times standard deviation contains almost 99% of our observation.